I have this very large piece of AAA quality amethyst, which I imported myself directly from the Anaheim mine in Bolivia. It's kind of shaped like a briolette, and I haven't cut a briolette in ages, so I decided to cut this specific gemstone into a briolette design. So I searched all the places on the web that I know of, and in all my books and notes, for a good briolette design for this piece of amethyst, but I didn't find an existing design that I liked or that I felt really worked for this specific piece of rough. So I decided to use my Gem Cut Studio or GCS software to create a unique gem fasting diagram for this piece of rough. I cut this piece of rough into a briolette while I was designing the design and published the final briolette in my last video. And I think it turned out great. So I've shown you the gemstone before the GCS cutting instructions. Anyway, here's a link to that video should you like to see how I cut this briolette. Now, I'm not an expert on GCS, Gem Cut Studio, at all, but a couple of years ago I decided to learn all about GCS, so I started going step by step and teaching myself GCS. Along the way, I created a number of GCS tutorial videos so that if you want to learn about GCS, you can just go to my videos and follow along, and you should be able to learn to use GCS. For your convenience, I created a GCS playlist on YouTube where I put all of my GCS videos and only GCS videos. And I also added all the GCS tutorial videos created by anyone else on YouTube, not only my videos. So here's the link to that playlist where you can find all the videos on how to use GCS. And if I missed adding someone's GCS video to the playlist, just let me know and I'll add that video also. The goal was to have all the GCS tutorial videos available in one place. So let's get started on designing this briolette. I've covered what I'm doing here on the screen in GCS in a number of prior GCS tutorial videos, so I won't spend a lot of time explaining the steps I'm using here. I just refer you to the earlier videos if you don't see what I'm doing or you don't understand how I'm doing something here in GCS. So I'll start our briolette design by cutting 16 facets at a 90-degree angle, and that will set the width of my briolette and provide a girdle. In this case, it's going to be a temporary girdle, and I made a note in the instructions of the design that you will need to, first thing you need to do is to cut a temporary girdle. And that's because later GCS is going to delete this girdle row of instructions. And once I cut through the girdle, and I'll show you that later. So at a 90-degree angle, I cut one facet at every 6 index teeth, starting with the 96 index tooth. And as you can see in the instructions, that means you will cut a facet at the 96, 6, 12, 18, etc. index teeth, all the way back to 90. Again, this forms a temporary girdle, and the purpose is to set the width of the briolette. And the reason I'm going to cut the girdle away later is because I want to create a whirlpool effect from the top to the bottom of the briolette. And so where the girdle normally separates the crown and the pavilion, I'm not going to have a girdle. The facets are going to touch each other and continue on with the whirlpool effect. And you'll see how this works later. So let's start with the bottom half of our briolette, or for GCS, the pavilion. Now I envision my briolette to be shaped like a kind of a half of a ball on the bottom side. And to create this effect, I need steeper angles on the bottom than on the top half of this briolette. So I will cut each row on the pavilion at 7 degrees steeper or 7 degrees less of an angle than the previous row or tier, except at the very bottom of the briolette. For that row, I'm going to do a step cut to kind of end up the bottom. I think it'll add a nice look to the bottom, and I'll show you that row or tier later. So this row will be called P1 as it's the first row of the pavilion. For now, GCS is calling it P2. But that will change once we get rid of the culet and turn this pavilion into a half a ball. So if I just deleted the current culet or P1, things get a little messy. So just bear with me here for now, and this row will be called P2 for now, but later and in the final instructions, it's going to be called P1. So we will cut this row at an angle of 83 degrees. That's 90 degrees where we cut the girdle, minus 7 degrees. Again, I'm going to cut 16 facets, symmetrical cut all the way around. Every 6 teeth, I'll cut a facet. And again, I'm going to start with the 96 index, same as I did with my temporary girdle. For my GCS design, I use the slider and just kind of eyeball how far I will need to cut this row of facets down the stone. For my actual piece of rough, I'll be able to calculate the length of the pavilion, or how far, how long the pavilion should be. Because when I'm done creating my design in GCS is going to make a number of calculations and give me another number of ratios, including the P to W, or pavilion to width ratio. And the pavilion to width ratio will tell me given how wide the stone is, it'll tell me how long the pavilion will be. So I'll tell you that the PW ratio, if the PW ratio ends up with 0.5, that means once I cut a temporary girdle and measure it, I have the width. Suppose the width is 12 millimeters. You multiply the 12 millimeter width times your P to W ratio of 0.5, and that tells you the pavilion will measure 6 millimeters from the bottom of your stone to the top of the pavilion. But for now, I just need to eyeball an amount to cut. And then cut, and my first row is complete. This will be row 2, P2. For now, again, GCS is calling it P3. So it's just a matter of repeating the information for the remaining rows of the pavilion. I will add 1 to the starting index tooth of the facet that I'll cut. On the last row, I cut at the 96 or 0 index tooth. So this row, I'll cut at the 1 index tooth, and every 6 index teeth after that. So the 1, the 7, the 13, the 19th tooth, etc. And for this row, again, I will subtract 7 degrees from the last row, which was cut at an angle of 83 degrees. So this row will be cut at an angle of 76 degrees. I will add a meet point so that this row of facets just touches the P1 in the girdle, and cut. This row will be P3. For this row, we again add 1 to the index tooth we're going to cut, so this will be the number 2 index tooth, and then we'll cut every 6 again, so the 2, the 8, the 14, the 20 index teeth, and so on all the way around. And we set the angle, again, 7 degrees less than the previous angle of 76 degrees, so this angle will be cut at 69 degrees. We add a meet point to just touch the previous row or tier, the one that will be P1, and we cut. And this will be row P4. We just keep repeating our instructions. We add 1 to the index teeth to be cut. That gives us the whirlpool effect. And we subtract 7 degrees from the previous row, and we add the meet point to meet the previous row. So we start with the tooth 3 of our index, and then cut every 6 teeth, and we cut at an angle of 62 degrees in this case, to set the meet point to meet P2, and again we cut this tier in GCS. This will be row P5. For this row, we add again 1 to our index teeth, and we start with index tooth number 4, and cut every 6 teeth. So again, the 4, 10, the 16, etc. index teeth. For the angle, again, we subtract 7, and we cut at an angle of 55 degrees. And we set the meet point to meet the P3, and cut. This will be row P6. And note, when I cut this tier or row in GCS, the culet, or the original P1, will finally disappear, and GCS will renumber all the other rows that I've cut for me automatically. So this P7 will become P6. Again, the culet's finally cut away in GCS, and all is right with the world from now on with this design. Again, this will be row P6, and for this row we add 1 to our index teeth, and we start with tooth 5 and cut every 6 teeth, so the 5, the 11, the 17, etc. For the angle, we subtract 7 degrees, and we cut this tier at an angle of 48 degrees. We set the meet point to meet the P4, and we cut in GCS. This is row or tier P7, and for this row, again, we add 1 to our index teeth, and we could start this tooth with index tooth 6, but that's the same as starting with index tooth 96. So again, we go back to 96 and cut every 6 teeth. So the 96, the 6, the 12, the 18 index teeth, and so on. Again, for the angle, we subtract 7 degrees, and we cut this tier at an angle of 41 degrees. We again set the meet point to meet the P5, and we cut in GCS. This is row or tier P8, and for this row, again, we add 1 to our index teeth, and we start this tier with index tooth 1, and again, cut every 6 teeth, so the 1, the 7, the 13, the 19 index teeth, etc. For the angle, in this case, we're going to subtract 7 degrees, 10 degrees, I'm sorry. We're going to subtract 10 degrees instead of 7 degrees. And we're just doing that just because I think it's going to look a little better on the bottom of our Briolette. You could subtract 7 degrees if you'd like, but I'm going to subtract 10. So I'll cut at an angle of 31 degrees, and I'll set the meet point to meet the P6, and again, cut this row in GCS. This is row or tier P9, and for this row, instead of adding 1 to our index teeth, I am going to repeat the same index teeth as the previous row or tier. So I'm going to start again with tooth 1, and that's because I've ended the whirlpool. I'm at the bottom of the Briolette, and I want to transition to kind of make a clean ending at the bottom of the stone. So I'm going to transition into a nice step cut for the bottom of the Briolette. I just think it's going to look better that way. You could do it either way, but that's the way I'm going to do it. So again, we'll cut every 6 teeth, starting with the 1, the 7, the 13, the 19, etc. And we just cut to have a nice step cut. Just eyeball it until that step cut looks just right to you. It can be halfway, it can be a little more, a little less. Whatever you think looks the most pleasing way for you. Again, for the angles, we're going to subtract 11 to round off the ball at the bottom of this Briolette. So I'll cut this at an angle of 20 degrees. And again, I'm not setting a meet point, it's a step cut. So cut it till it looks good to you, and then cut it in GCS. So now we're ready to cut the upper half, or the crown of our Briolette. Okay, to cut the crown, we select crown, not pavilion, in GCS. And this will be row C1. I want to cut the crown at less of an angle than the pavilion, because the less angles or less degree angles that you cut makes the facets longer. And so of course I want the upper half of our Briolette to have long facets and a longer crown and a short rounded pavilion at the bottom. So instead of 7 degrees, which I used in the pavilion, I'll subtract 4 degrees to each row on the crown. If you wanted your Briolette longer, you only subtract 3 degrees or 2 degrees or 1 degree on the crown part of the stone. But I'm going to subtract 4 degrees. So I select tooth 96, which will make this facet match up with the facet on the pavilion side, which I also cut starting with the 96 tooth. And when I get those two facets to line up, that's of course going to cut away our temporary girdle. So the temporary girdle will disappear, and the instructions for that girdle will also disappear. That's why I had to write in the notes of our diagram to start with a temporary girdle to set the width of the Briolette, because again, you won't see the girdle instructions with the final design because we're cutting them away. Row C1, 96 index tooth, angle of 86 degrees, again 90 degrees minus 4 degrees. I move the slider down until the meet point shows up with P1 facet. I hit jump and note that when I do finish this cut, the girdle is deleted in the instructions. This will be row or tier C2, and for this row we add 1 to our index teeth again, and we start in this case with tooth 1 and cut every 6 teeth. For the angle, again we subtract 4 degrees from the previous angle and cut at an angle of 82 degrees. We set the meet point to meet the C1 P1 facet, and we cut. This will be row or tier C3, and for this row we again add 1 to our index teeth, so we'll be starting with tooth 2 and cut every 6 teeth. For the angle, again we subtract 4 degrees from the pavilion angle and cut at an angle of 78 degrees, and we set the meet point to meet the C1 and we cut in GCS. For row C4, we again add 1 index tooth to start with index tooth 3. We subtract 4 degrees to cut at an angle of 74 degrees. And we set a meet point for C2, and again we cut this row or tier in GCS. And for row C5, we add 1 index tooth again, and in this case we start with tooth number 4. Go around our index scale then, starting with 4. We subtract 4 degrees to cut at an angle of 70 degrees, and we set a meet point for C3 and cut in GCS. This will be row or tier C6, and for this row, again, we add 1 to our index teeth, starting with tooth number 5, and we cut every 6 teeth as we did before. For the angle, again, we subtract 4 degrees from the previous angle and cut at an angle of 66 degrees and set the meet point to meet C4, jump to that meet and cut in GCS. And note that the table in GCS automatically disappears when we cut this row in GCS, as our Briolette now goes to a point and has no table, therefore the table instruction disappears. This will be row or tier C7. For this row, we again add 1 to our index teeth, and we could start with tooth 6, but again, tooth 6 is the same as starting with the 96 tooth if you cut every 6 teeth. So we'll start with the 96 tooth and cut every 6 teeth on this tier. Again, for the angle, we subtract 4 degrees from the previous angle and cut at an angle of 62 degrees. We set the meet point to meet C5. We jump to that meet point and cut in GCS. This will be row or tier C8, and for this row we add 1 to our index teeth again and start with tooth 1, and we cut every 6 teeth. For the angle, we subtract 4 degrees from the previous angle and cut at an angle of 58 degrees and set the meet point to meet C6. Jump to the meet point and cut in GCS. Okay, we're done with this design. Woohoo! So I've shown you how I designed the Briolette cut, which I cut our Amethyst from. I should have added the comments into GCS as I went along, which the comments are basically to meet where to meet the points at on each row. But I have added them, and you can see them in the diagram now. And again, this is the design I used to cut that specific large piece of AAA amethyst that I got from Bolivia, and I think it turned out great. If you do cut BOPIE'S whirlpool Briolette design, please drop me a line on Facebook and let me know what you thought of the design and of your final gemstone. Photos are always appreciated. And as always, happy fasting, everyone.